Good evening, everybody. Today we will discuss the factors which affect the electrophilic substitution reaction. There are three factors which affect the electrophilic substitution reaction. First one is substrate, second one is the leaving group, third one is the nature of the solvent used for the chemical reaction. So first of all, we are moving into the first factor, that is the substrate. You know that the electrophilic substitution reaction can be classified into three different categories: SC1, SC2, both front and back, then SCI. For SE1 reaction undergo through a intermediate carboanion. For SC2 reaction undergo through a transition state. And for the SCI reaction, the leaving group assist the electrophilic substitution reaction. So for SC2 backside mechanism, the preferred order of the substrate is methyl greater than ethyl greater than propyl greater than isopropyl, etc. This is to reduce the steric hindrance in the chemical reaction. So see, the second point is see the table in the bottom of the slide. So first one is methyl, second one is ethyl, third one is the propyl. So as the branching at the alpha carbon increases, the rate of the reaction increases. This is mainly due to the electron donating entity effect of the R group, which stabilizes the electron deficient transition state in SC2 front mechanism. Okay. Now, as the branching at beta carbon increases, the rate of a reaction decreases. This is mainly due to the steric hindrance. And for SC1 reaction, electron withdrawing group will increase the rate of the reaction because SC1 reaction undergo through a carboanion intermediate. These are the nature of the substrate which will affect the SC1 and SC2 reaction. Now we are moving into the next factor, that is leaving group. So leaving group will influence both the SC1 and SC2 reaction. Most probably the leaving group must be a electropositive leaving group, since the reaction started by an electrophile in SC reactions. So in SC2 reaction proceed with an alkyl group which is attached to a metal as leaving group. Example is organomercury. And for polar bond, as the bond become polar, more easier is the departure of the leaving group in SC2, SC1 and SCI reaction. If the leaving group is a carbon, which is most preferred in SC1 reaction, and metallic leaving group is preferred in SC2 and SCI reactions. These are the nature of the leaving group which will influence the electrophilic substitution reaction. Next we are moving into the next factor, that is solvent. Mostly the polar solvent favor the SC1 mechanism and less polar solvent favor the SC2 reaction mechanism. And the solvent will not affect the SCI reaction. These are the factors which affect the electrophilic substitution reaction. Thank you.